Hey everybody, I'm Matt here at the Bucks 3D Expo with Brad from Allegheny Education Systems. Why don't you tell us what you got here?
Educational Systems,
Educational Systems? Let's just keep going. Whatever. All right, we'll do it one more time.
So, hi, no. I'm Brad Chandler, Allegheny Educational Systems. We are a manufacturer's representative for the education market across Pennsylvania, New York, and New Jersey for many types of technical training equipment. And so what we have here is a bunch of our main manufacturers that cover mainly the makerspace market. Some people call it an innovation lab, some people call it a fab lab. It's always a space where people are making some really cool stuff.
Awesome. And you guys have a couple different technologies here, and we've been at other booths, and you're also representing those products and those companies as well.
Yeah.
Why don't we talk about what we have right here?
Sure. So this is the Wazer. It is your standard water jet sort of system, but packaged so that it's great for education. In the industrial setting, water jets can get pretty messy.
Absolutely.
You sort of need a space unto itself. But this lid closes. The system is fully contained, and the software is real easy to use, and basically it allows students and educators to basically cut materials that they normally can't cut on typically a laser or CNC a lot of times. So, or sometimes they don't have the space for the equipment that it takes to cut steel, to cut aluminum. There's some safety issues that
Lots
come
of
into
electricity
play,
too.
in education. But with a water jet, you can cut metals, but you can also cut something that pretty much none of our other equipment can cut, which is flexible materials like silicone and other rubbers, elastomers, that basically you're not going to be able to cut them on a laser, you're not going to be able to cut them with CNC. Yeah. Water jet's the only way to go.
That's so cool.
Yeah.
And what type of accuracy are you getting, just roughly? Is it the same as laser, a little bigger because of that water?
About the same as
about
laser.
The same.
Yeah,
Wow.
slightly bigger.
And this is also cutting ceramic too.
Yes, ceramic, aluminum, copper. I forget what else we have here, actually.
So you could see a lot of applications, not only for engineering classes, but also in the arts space, that you could cut parts for that and go into that. Very cool.
Absolutely. Yeah. So let's actually go over to our tried and true Epilog laser engraver cutters. So this is a combination machine. They've pretty much always been that way, that they can not just laser etch silly signs where you have to know how to spell things correctly, but they can also cut through a wide variety of materials. Using either CorelDRAW or Adobe Illustrator, students are able to pump out a lot of really cool projects, but also iterate some projects in real cheap material, cardboard, paper, coroplast, acrylic. And so you're able to pump out either mock-ups or real-life parts.
Yeah, absolutely. And I'm sure glass as well you could do on this type of product?
So there's certain materials that you can cut all the way through, different types of wood, engineered woods, plastics. Then you can also etch things, etch coatings off of things.
So like remove an anodization or something from a product?
Yeah, so anodized aluminum, you can basically etch the anodization right off of it. We don't have any of our other...
Right there?
There we go. Yeah, so we made these bottles at the show.
Cool.
I went to the Bucks County Community College 3D Printer Expo, and all I got was a lousy laser-etched bottle. So a lot of people came through the
That's
expo
awesome.
and got those.
That's so cool.
And we were just making them on an attachment here. There's a little rotary attachment that allows you, it basically takes your graphic, wraps it around the object that you throw in there. So you can do glass, you can do anodized aluminum bottles, all sorts of things.
So for customization, you can do one-off. You could put somebody's name on it. You could laser etch that right here while they're there.
Yeah, so when schools aren't using them for prototyping or engineering courses or art courses or graphic courses, they're also using them for like after-school clubs. And making things for the school store, making things for entrepreneurship, that sort of stuff.
Great, so multi-use products.
Yeah, absolutely.
Very cool.
So then what we're mainly here for, the 3D Printing Expo, we sort of displayed a lot of the various technologies that we represent, that are represented here by the individual manufacturers. But I sort of set it up so that we can go across the table here. So FDM, fused deposition modeling, has been around a long time. Stratasys is the inventor of that technology. We've been a long time Stratasys representative in the education market. So that is your, taking filament, melting it, and then laying it down layer by layer. That's fused deposition modeling. As the technology has grown over the years, it's also gotten less expensive. It's become more accessible, and so then it started to incorporate colors besides just plastic. You could have various colors of plastic, different types of plastic. So ABS was like the first one. ABS is the same plastic is what Legos are made from. But then we have other plastics, maybe more environmentally friendly. PLA, it's also a less expensive material. And so in 3D printing, in the 3D printing space, FDM has been around a very, very long time. Stereolithography, and so what's been added to FDM has also then, there's also other technologies that have been added along the way while FDM is still advancing. So FDM is still the
valid,
very
progressing,
wide,
absolutely.
Very wide use, but now we're doing things like adding carbon fiber into the polymer as it's being built to give you 30% more strength.
That's incredible.
In a part. So not just for prototyping, not just for toys, although that's a lot of fun, we're now, and have been for quite a while, in the manufacturing space.
So real, either prototyping a part that is then strong enough to be used.
Yep.
So one-off tooling,
yeah.
Sure.
So tooling, fixturing, that sort of thing. And so additive manufacturing is really sort of still exploding, even though it was adopted as soon as prototyping was, pretty much. All right. So this is just a variety of different types of FDM built parts, and then pretty much everybody's probably familiar with seeing the inside of those parts.
Absolutely.
With the hexagonal sort of sparse design to save on material. Then, as that technology was progressing, that's where stereolithography also sort of started around the same time, but has become much more accessible from Formlabs. Formlabs uses the low-force stereolithography in order to build very, very smooth parts and very, very detailed parts that really, quite frankly, we can't get with FDM. We're looking at micron size layers rather than tens of thousands of an inch or something.
Sure.
At the same time, so Formlabs has a wide variety of mechanical properties, various materials, as well as colors and flexible materials as well, and also biocompatible materials. Again, yesterday I'm really excited about the medical, the dental markets that where this stuff is being used. Yeah, and then a separate technology, polyjetting, which also uses resin, but is actually spraying that with a mixture of color and a mixture of other materials that have different properties. You can is available from
So it's
Stratasys.
similar to the inkjet printer type of technology, where it's depositing the material on top of.
It's actually spraying it out of a piezo, but very, very precisely.
Yeah.
And then curing it.
As it's going.
Right? Yeah.
And that was the spinning plate that we were looking at earlier.
Yeah, exactly, on the J55. And so that, with a combination of material properties and colors, you can get all of these different types of parts, where you're getting full color, but also flexible pieces all in the same build. This is great for product design, graphic design, package design, toy design, that sort of thing.
Incredible.
Yep.
Thank you so much.
Yeah, sure. Then the one other thing that I wanted to add along with that technology, what they've added is the ability to make bone matrix, tissue matrix, radio matrix materials that can mimic and replicate real bone structures, real tissues.
So I remember in one of the panels yesterday, they were talking about a doctor was printing aneurysms.
Yeah.
And that is incredible to think that you could
save lives.
Save lives with this technology.
3D prints.
Yeah, so cool. Awesome. So who should reach out to you?
Basically any educational institution. We cover all educational facilities within Pennsylvania, New York, and New Jersey. And we provide consultation, support. We'll do a site visit to see if you have the facility necessary to get set up, and if you don't, we'll help you figure that out. And we provide on-site installation, training, and support for the life of the machine as well.
Awesome.
In a variety of ways all across the territory.
Awesome. Thank you so much.
Thank you, Matt.
Thanks, everybody.